right, say we're going to work with our quadrilaterals in the coordinate plane. So by this point, you should have finalized and completed working with all your quadrilaterals, so parallelogram, rectangle, rhombus, square, trapezoid. All right, you should know all the properties, and you should have gone back into each packet and filled in those first sheets to help you organize your thoughts. All right, and likewise, this packet has that as well. So what we're going to do today is on a coordinate plane, we're going to use what we know about all the properties of our quadrilaterals. Okay, and we are going to use our length, slope, and midpoint to help us figure out which quadrilateral we are looking at, as specific as we can get. All right, so in this packet, the first 3 pages are actually for you to do on your own, to go back and fill in those questions. Really think your way through. You're only hurting yourself if you are not taking advantage of this tool. Okay, if you're not going to go through and fill these in, you're going to struggle. So make sure you're doing that. So I'm going to skip the first 3 pages for now. Okay, so let's get started. Number 1 says, using lengths, determine the most precise name for quadrilateral ABCD, and we see the sides that we're given. So our directions are we have to use lengths. So we're not using slope, we're not using midpoint, we're using length. So let's think for a minute. Let's formulate a plan. Why would we be using lengths? Okay, lengths can tell us for congruent sides. So one thing we're looking for are congruent sides. So let's think about our different shapes. In a parallelogram, we need 2 pairs of opposite sides congruent. Okay, we can get more specific. In a square rhombus, we could have all 4 sides congruent. So we are going to use lengths to help us identify, first of all, is this a parallelogram? Okay, and then second of all, can we go further? Are all 4 congruent? All right, but then we also need to decide whether the diagonals are congruent or not. Okay, so we're only using lengths. So we got to think, what can we find the length of? And we'll talk about that in a second. So let's start by plotting. Now these points, guys, kind of go far off the screen. So what I'm going to do, and that's up to you, is I'm going to move this x-axis. So I can't really move it, but I'm going to redraw it down here and pretend that other one doesn't exist. So what I'm doing is I'm opening up my first top 2 quadrants, okay, so that I have more space. So I'm going to treat this as my origin. This is 0, 0. And I'm going to ignore this one up here. Okay, so I'm going to go ahead and plot my points. So A is located at 2, 5. So for my new origin, I go over 2, up 5. And then here's A. B is at 5, 8. So 1, 2, 3, 4, 5, up 8. 1, 2, 3, 4, 5, 6, 7, 8. And I put B. C is at negative 2, 12. And this is why I had you move it. Negative 2, up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then D is at negative 5, 9. 1, 2, 3, 4, 5, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm going to go ahead and draw my diagram. Now, I know this is a quadrilateral. Why? Because there's 4 sides. Okay, so we've got that ruled out. So we're just going to get more specific. Can I prove it's a parallelogram? If so, can I then go further? Can I say it's a rectangle or this or whatever? Now, if we're only using lengths, that means we're not finding angle measures. So that should tell me that it's probably not going to be a rectangle or a square, because if it's going to be either, I need to show that both of them have right angles, and finding lengths is not going to help me. All right, but we'll talk about that in a second. So go ahead, find the lengths of all 4 sides. All right. All right, so if we're going to prove parallelogram first, we need 2 pairs of opposite sides are congruent. So I'm going to do DC and AB first because they're the opposites. So the length of DC, all right, so I'm going to go up and over. So it's up 1, 2, 3 over 3. So that means it's going to be 3 squared plus 3 squared, which is 9 plus 9. So it's the square root of 18. The length of AB is up 3 over 3. Okay, well, instantly I see my numbers match, but we're going to go ahead and just show it. So the length of AB, once again, is 3 squared plus 3 squared, which is the square root of 18. Okay, so right now I have 1 pair of opposite sides are congruent. So I'm going to put a little hash mark there. Bam and bam. Okay, now I'm going to do my others. DA and then CB. Okay, so the length of DA, 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7. So 4 squared plus 7 squared, which is 16 plus 49. All right, which brings me up to the square root of 65. And then CB, 1, 2, 3, 4, and 7. All right, so same number, so yes, okay? Both of these are the same length. So what that tells me is that I have two pairs of opposite sides are congruent. So at this point, I can conclude that ABCD is a parallelogram. Okay, it is a parallelogram. But can I go further? All right, once again, I'm doing length, so I know it's not going to be a rectangle because I'm not looking for right angles at the side. But, I'm sorry, let me rephrase that. I'm not using angles to prove it's a rectangle. Okay, another way we can talk about whether it's a rectangle or not is using our diagonals. All right, we know it's not going to be a rhombus or square. Why? Because in order to be rhombus or square, all four sides have to be congruent, and I have two pairs here. So it's not going to be that. Did anyone notice my big blurring mistake right there? Sorry. Okay, so it's not going to be rhombus or square, but we can look at our diagonals to decide if it is a rectangle or not. All right, how am I going to do that? Well, in a parallelogram, if it's a parallelogram, the diagonals do bisect each other, but they're not congruent. In a rectangle, my diagonals are congruent. So I'm going to go ahead here, and I am going to find the lengths of the diagonals the best I can, because this thing is drawn all over it. All right, so from D to B, so down 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so DB is my one diagonal. So it's 1 squared plus 10 squared. So 1 plus 100. Okay, so it's the square root of 101. And then my other diagonal, C to A, is going to be down and then over. So it's over 1, 2, 3, 4. Down 1, 2, 3, 4, 5, 6, 7. All right. That's a square. So I get 16 plus 49. Okay, so that's actually the same length as the other sides, but they're not congruent. So therefore, since the diagonals are not congruent, it's not a rectangle. So the most precise name that we can come up with is a parallelogram, because I have two pairs of opposite sides that are congruent. And I cannot get more specific because my diagonals are not congruent, therefore it's not a rectangle. So the most specific name for this is a parallelogram. Okay, so we're using the information we're told to use to identify as most specifically as possible the name of it. All right, let's go ahead and flip the page. Okay, the next one's saying to us using slope, length, and, oops, sorry. I didn't mean to flip the page, I meant to scroll down. All right, so in problem number 2, it says using slopes, determine the most precise name for a quadrilateral. Okay, slopes. What are slopes going to prove? They're going to prove, we can use it to talk about parallel. Okay, if slope opposite sides are parallel. And then we can use it to talk about 90-degree angles. So let's go ahead and let's plot our points. So A is at 1, 3. B is at negative 3, 1. C is at negative 1, negative 3. And then D is at 3, negative 1. Okay, so here is this quadrilateral. Okay, so using slopes. So let's first find the slopes of the outsides, okay? Find the slope of the outside to determine if it is indeed a parallelogram. Okay, opposite sides have to be parallel. And then also talking about the angles that they meet at. So slope of BA is up 2 over 1, 2, 3, 4. So the slope of BA is, we said, was up 2 over 4, which is also known as 1/2. Okay, the slope of CD is up 2 over 4, which is 1/2. So those opposite sides are parallel. Okay, the slope of CB, or BC, is down 4 over 2, so it's a negative slope. Down 4 over 2 is also known as negative 2. And the slope of AD is down 4 over 2. So it's also negative 2. Okay, so what does this tell me? This tells me that I have two pairs of opposite sides parallel. So for right now, I have a parallelogram. Two pairs of opposite sides are parallel. Okay, I need to see if I can be more specific. In the last example, we couldn't. Parallelogram was all we got. But we're going to see, is this more specific? If opposite sides are parallel, can I show it's a rectangle, a rhombus, or a square? Okay, so once again, I'm told to use slopes. So go back to your diagonals, guys. Okay, a couple things you also can notice. because I've already found the slopes of the outside, if I look right here where BA and CD intersect, I'm sorry, BA and BC, here's BA, here's BC. Those slopes are opposite reciprocals. What does that imply? Well, that implies perpendicular. So that means that this is a 90-degree angle. Okay, it is a 90-degree angle. So what does that tell me now? Well, it tells me my outside angles are 90 degrees, so that's specifying I'm now down to, I can show that's either a rectangle or a square. Okay, so I'm kind of like working my way down the ladder here and saying, how specific can I get? But which one is it? And how are we going to distinguish between the two? If I have no other information at this point, I can say, hey, this is a rectangle. Okay, opposite sides are parallel, so it's a parallelogram. I prove four right angles, so therefore it's rectangle. But let's say, can we find out if it's a square? How are we going to know? Well, one way would be to do the lengths. Are all the sides congruent? But my directions tell me I have to use slope, so I've got to think in terms of slope. So go back to what else you can find a slope of. Our diagonals, okay? Our diagonals, if this is a square, think back to your square and rhombus, they will meet at a 90-degree angle, okay? Slopes of squares and rhombus of the diagonal are perpendicular, so same kind of concept. Now my line is kind of drawn really off here, but you get the point. So I'm going to do A to C first. Let me use red, something different. So from C up over, I go up 1, 2, 3, 4, 5, 6 over 2. So the slope of CA is 6 over 2, which is 3. So the slope of BD, my other diagonal, I go down 1, 2 over 1, 2, 3, 4, 5, 6. So the slope of BD, and this is not length, I'm finding its slope, is down 2 over 6, which is negative 1/3. So what does that tell me? It tells me my diagonals meet at a 90-degree angle because their slopes are indeed opposite reciprocals. Okay, so the diagonals are perpendicular. So that means that I can rule out a rectangle because the diagonals of a rectangle bisect each other, but that's it. The diagonals of a square prove that if they meet at a 90-degree angle, they're perpendicular. That means it's a square, okay? Why is this a square and not just a rhombus? Well, opposite sides are parallel, so it's a parallelogram. The sides meet at a 90-degree angle. They're perpendicular, so that means square rectangle. And we decided it was a square because the diagonals are also perpendicular. So because of those three things, this is a square. So it really helps, guys, if you know your properties. Okay, on to the next one. All right, in this problem, we are told that we are going to use slope, length, and midpoint, so a whole shebang, to determine the most precise name. So let's go ahead and let's plot our points. So P is at negative 2, 4. Q is at 5, 6. Okay, R does run off the paper, so we're going to do the best we can. 6, 7, 8, 9, 10, 11, 12, 4, 1, 2, 3, 4. Okay, and then S is at 5, 2. Okay, there is my quadrilateral. All right, so it says using slope, length, and midpoint to determine the most precise name. Okay, let's start with our diagonals, guys, because we can prove a couple things there. We want to prove, first of all, if our diagonals bisect each other. If they don't bisect each other, it is not a parallelogram, so we can stop there. So it's actually going to be quicker than looking at the sides, the lengths, or parallel sides, because if our diagonals do not bisect, meaning we'll use midpoint, do they cross the same midpoint? Okay, we can decide first, hey, is this even a parallelogram? So PR, what's nice about these is this is completely vertical. I'm sorry, that one's horizontal, this one's vertical. So PR is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So half of 14 is 7. 1, 2, 3, 4, 5, 6, 7, which is right here. QS is 1, 2, 3, 4. Half of that is 2, which is 1, 2 right here. Okay, so they do have the same midpoint. Diagonals, same midpoint. What does that mean? It means that the diagonals bisect each other. So that's telling me, hey, at this point, I can conclude it is a parallelogram. But now we're going to say, can we go further? Can we be more specific? Okay, so we've got that taken care of. Midpoints helped us. All right, so let's be more specific. Let's go ahead and look at side lengths to decide, okay, well, is it going to be a specific parallelogram or just a parallelogram? So in order for this one, we don't have to necessarily find all four sides. If we find two next to each other, okay, because I've already proved it's a parallelogram, so I know P, Q, and S are congruent, and I know P, S, and Q are have to be congruent because I already said it's a parallelogram. So if we find, okay, well, the two next to each other, if they're congruent, it rules out rectangle. If they are not, it rules out rhombus and square. All right, so I'm going to take a look at PQ and QR and find their length. So PQ is 2 and 1, 2, 3, 4, 5, 6, 7. Okay, so the length of PQ is going to be 2 squared plus 7 squared, which is 4 plus 49. So it's a square root of 53. And then QR is 2 and 7. Okay, so they are. So what does that tell me? Just to recap while I'm writing, why did we do that? We already know it's a parallelogram because the diagonals bisect each other. So I already know that the opposite sides are congruent and parallel. Now I'm finding out, are the two next to each other? Because if they are, it tells me, hey, since PQ and QR are congruent, this is not a rectangle. Because in a rectangle, congruent or consecutive sides are not congruent. So this is either a square or a rhombus. Okay, so we've used length, so let's use slope. How are we going to use slope? Well, what distinguishes a rectangle from a rhombus? The angles, okay? The angles. In a square, the angles are right angles. In a rhombus, they are not. They're something else, okay? Whatever it may be, depends on the problem. So let's use slope to find it out. So PQ and QR, we've already done all the work. We need to find out, do they meet at 90-degree angles? Okay, so the slope of PQ is 2 over 7. So now I'm doing slope. The slope of QR was down 2 over 7, so negative 2 over 7. So guys, are those opposite reciprocals? No, that means they do not form 90-degree angles. They are not perpendicular. So that means it is not a square. Because the angle or the sides do not meet at 90-degree angles, it is not a square. So that means that this one is a rhombus. Okay, we proved a parallelogram, and then we proved rhombus because all four sides are congruent. All right, and look at your diagonals. They meet at a 90-degree angle, which happens for their slopes are opposite reciprocals, okay, of the diagonals. So this one is a rhombus. So we are using all these tools to kind of go through and prove which one it is. It really helps if you're thinking on the way through, okay, what does this show me? What possible quadrilateral could this be at this point? And then kind of use your process of elimination. Okay, the last problem. The last problem you guys are going to do on your own. So I'm going to pause the video and I'm going to do it too. And then you're going to press play and take a look. If you got it right, you're done. If you didn't, stay on the video and listen to the explanation. Okay, but I want you to think your way through. Notice, I don't tell you to use whether you're using slope, length, or midpoint or whatever. So you've got to think it through. Draw it and think, okay, what can I do? Where can I start? Start with a parallelogram and then go from there. So right now I'm going to pause the video. All right, if you got rectangle, you are correct. So what I did was I first started to say, hey, is this even a parallelogram? Because if it's not, I'm just done there. So multiple ways you can do it. You can prove opposite sides parallel. You can prove opposite sides congruent. However you want to do it. I did the diagonals. Do they bisect each other? Because A, I wanted to practice my midpoint, and I thought that was the easier way to go. But whatever, it's fine. Okay, we didn't specify. So my diagonals did bisect each other. They both crossed at the point. It's in black here. 1.5, -1, 2, and -2.5. Kind of hard to see because my obviously drawing is freehanded. I did the best I could do. All right, but they do cross there even though the green lines don't actually cross at that point. So since the diagonals bisected each other, that meant, hey, this is a parallelogram, okay, because that happens. What I could have done there to prove if it was rectangle was I could have just found the length of the diagonals, all right, or I could have looked at the angles where they meet and find out if they're right angles. So what I did was I found the slope of SP, which was 5/3, and the slope of SR, which was -3/5. So that means that SP and SR meet at a 90-degree angle. So that tells me that those are 90-degree angles. So it is a rectangle. So then from there, I could decide if it's a square or not based upon, hey, are all 4 sides congruent? And they're not. Okay, the length of SR is 9 or 3 and 5, so 9 plus 25, so the square root of, so length SR is the square root of 34, it's 9 plus 25, and then the length of SP is up 10/6, so it's the square root of 100, I'm sorry, yeah, the square root of 100 plus 36, 136. So what's that tell me? That the sides aren't congruent, so therefore it's not a square. Okay, so I proved this parallel by proving my diagonals to bisect it, cross the same midpoint, meaning that they bisect each other. I then proved right angles. Okay, I also could have just done by my diagonals, are they congruent? Because that shows me rectangle as well. So there's multiple methods here. And then I saw that it's not a square, okay, because all sides aren't congruent. So that's as far as I could go. All right, so at this point you are done. Please bring any and all questions to class. Oops.